Hello, welcome to another video lecture of Astronomy OpenStax. Here we'll be looking at Chapter 12, do a quick overview of the rings, moons, and Pluto. So 12.1, here we look at the rings and the moon systems. And so here's just kind of a collage of some of the different moons and Earth here kind of as a reference. So you can see some of these moons are fairly large, comparable to the moon of Earth itself. Three different types of moons, sizes: small moons, under 300 kilometers, medium-sized moons that go up to about 1,500 kilometers, and then large moons, which are over 1,500 kilometers. And the large moons are very interesting to us because we see that there's still ongoing geological activity, which means that they are geologically alive, right? So they are very active on the surface. Medium and large moons here in this collage, you can see towards the bottom, Mercury, the moon, and Pluto are listed there. And one of the moons of Jupiter, Ganymede there, right, supersedes all of those. So some of these are extremely large. If they orbited around the sun, we would consider them planets in their own right. But since they orbit another planet, we consider them satellites or moons. Small moons are typically just captured debris, space junk. So Jupiter has around 70 moons, but a lot of those are just captured debris. Really, what we'll focus on for Jupiter are the four main moons, which we call the Galilean moons. And so that'll lead us into 12.2. Galilean moons, named after Galileo, who was able to discover them just with a telescope, no stronger than probably a pair of binoculars. I was able to detect those objects. If you recall, he noted that they were able to go around another body, and so that gives some argument that the Earth did not have to be at the center of the solar system. So let's start off with Callisto. Callisto is kind of just a cratered ice ball. Old surface, and we see that because there is a lot of cratering still on it. And we see that it has a magnetic field. And this leads us to believe that maybe it might have a buried ocean underneath. So if you have a magnetic field, that means that you have to be rotating and you need to have a heat source. And since this is a ball of ice, if there's a heat source, then we anticipate that it's perhaps melted on the inside. And so that's what leads us to believe that there's perhaps a buried ocean. Here we could see some images of the different terrain there. And we can see this kind of jaggedy terrain here that's has about 80 to 100 meters tall, and it tends to erode. And on that bottom image on the right, you could see that it leaves behind kind of some impact craters that are exposed after that erosion there. Ganymede is the largest moon in the solar system, and we see that there's some clear evidence of geological activity. This is due to tidal heating. We'll talk about that a bit in the later section. But here, this image in the bottom, you could see that there's old terrain that's heavily cratered, and then we see kind of a smoother, younger terrain. And there's a clear distinction between the two. So something happened there where it smoothed out the surface. So we anticipate that there is a geological activity happening now. Here are some other images. On the left, we see those darker images are going to be older parts of the surface that are more heavily cratered. than the lighter regions. And on the right, we see some of these lines and grooves and ridges that appear to cut through kind of some of these craters here. So uh, that indicates that there is some type of activity that had happened there. Europa is what we consider a water world. So we're pretty confident that there is a liquid ocean underneath the surface. There is, it's heated by a tidal heating as well. Here we can see evidence when we look at the ice on top and the way that these grooves kind of crack. It resembles or looks very similar to floating sea ice and icebergs in the Earth's Arctic Ocean. On the right, we see kind of these ridge lines that intersect with older ones and younger ones that tend to cross over. So that kind of implies that there's a natural flexing of the moon itself. So kind of stretching and compressing. Here are some artist renditions, the first two images. So of what we think the core is inside, so some type of a metallic core in there, and then a rocky interior, and then a water layer. And that image in the middle is what we think is there's a thick layer of ice and then a water underneath, again with a heat source. That's what is creating that liquid ocean underneath. And the image on the right, we see kind of these icebergs that are suspended over this kind of liquid slushy water. Io, very interesting. This is the most volcanically active body in the solar system. So we see evidence of volcanoes that are erupting continuously and are changing the surface actively. So that's happening currently today. We also have images here. We see lava fountains on Io. And on the left there, we could see fresh hot lava that's erupting from the ground. So very, very active volcanically on Io. So the question is, why are they so active? Why are these moons so active? They're extremely small, and if we think about Mercury and the moon, they're very small, so the heat has left them. They're geologically dead. Uh, Venus and Earth, which are larger, are very active. So why is it that these smaller moons are still very active and very much geologically alive? So what happens is with Io is its orbit around Jupiter is very elliptical. And the gravitational influence of Jupiter tends to kind of squish it and release it. So kind of like a squishy ball. And so when it gets closer to it, it's stretched out, elongated, and then when it's further away, it kind of releases. And it creates this kind of bulge, or it creates this actual friction as that happens. And so that starts to create some heat. And since it's mainly made up of water compounds, not so much rock metals, all you need is a little bit of heat, a little bit of friction to melt that and make it more geologically active. So that begs the question, why is the orbit so elliptical? And this has to do with orbital resonance. Io, Europa, and Ganymede are in synchronous or are in sync rotation here. So for every orbit that Ganymede does, Io does 4 orbits. So they always end up lining up. And when they line up in a row, they all tend to tug on each other. And so that gravitational influence pulls on it, making that orbit more elliptical. And so for all 3 of these moons, we get that tidal heating that compresses and stretching them out. So they all have a fairly high elliptical orbit. Titan, which is Saturn's moon, and Titan is the only moon that we see that has a very thick atmosphere. It consists mostly of nitrogen and methane and ethane, which is toxic to us, but nonetheless still has this atmosphere. The structure of the atmosphere here we see kind of has these thick clouds, but it does produce kind of this rain. Again, methane and ethane, which is hazardous to us, but it does create rainfall. And so it creates these lakes of liquid on the actual surface. So here we see some images of these boulders that are actually composed of water, ice, and methane. And here are some images of the lakes of Titan. And so one of the key things that makes life sustainable here on Earth is that we have liquid water on the surface. That's the key thing. And so here we find another body that has a liquid on the surface. Again, composed of some compounds that are going to be hazardous to us. But if we're talking about some type of life form that is evolving there, right, maybe in the form of a bacteria or something, it could be possible that it's sustainable there. But very interesting that it has an atmosphere, which again is one of the conditions that allows the Earth to flourish with life, is that atmosphere protects it, and then we have that liquid on the surface. So Titan has 2 of those conditions, not water, but still composed of methane and ethane there. So Saturn also has lots of medium-sized moons. And typically for medium-sized moons, very small, we anticipate that they would have activity in the past. And we see lots of evidence of that, of volcanoes and plate tectonics. But more interesting is Insidious here, which when Cassini did a flyby, it actually saw these fountains of water vapors coming out from the surface. And you can see those there on the bottom. And so this means that it is geologically active. A body that we did not think of that size could still be having a heat source. It actually does. And so this really makes us rethink what we know about these medium-sized moons. Medium moon of Uranus here. We see this moon, Miranda, has a very large tectonic features. So some past activity there, large mountain range, and very few craters. So perhaps contributed to tidal heating in the past. Neptune has an interesting moon, Triton. And Triton is very similar to Pluto, but larger. We also see evidence of past geological activity. And we think that it's a captured moon because it actually orbits backwards. So when the solar system formed, the cloud condensed, heated, and started rotating. So all the planets, or majority of them, they rotate, right? They orbit in the same direction, and also they orbit and they rotate in the same direction. Except for Venus, which goes backwards, we think that early on in the solar system, during the heavy bombardment, an object collided with it. But this moon also orbits backwards in the opposite direction. And so we think that it was a captured moon at some later time. Considering that it's similar to Pluto, perhaps it was a captured object from the Kuiper belt, which is this region in the outer part of the solar system that has a lot of leftover debris. And that's similar to where Pluto comes from. And then here we see Triton's geysers here. So again, more evidence of this past activity. So why are the Jovian planet moons more geologically active than the small rocky planets? We touched on this a bit, but it has to do with that they're mainly made out of ice, and ice melts at lower temperatures. So tidal heating ends up being driving activity. Tidal heating is enough to melt that ice and make that heat source. For terrestrial planets where we have rock, metals, we need higher temperatures for those to make things geologically active. So that leads us into Pluto. And here's kind of a collection of other objects that are beyond Pluto in the Kuiper belt here. And Pluto lies beyond the orbit of Neptune, was considered at one point the ninth planet. That has been modified in 2006 when objects beyond Pluto that were larger were also detected. So Pluto's motion, very difficult to detect here. You have to look at some images and then look at it again over some time. Here we see a couple days, almost a week in separation, where a little faint object had moved its location there to detect that. So we see that Pluto was kind of an oddball. At some point, its orbit went inside the orbit of Neptune, so very highly elliptical. And it wasn't, that Jovian gas giant, but it wasn't also a terrestrial. So it never quite fit into which group it was. There was always thought that it was something different. And so about 2005, we detected Eris that had a more eccentric orbit, so a lot more oval-shaped orbit there. It was larger than Pluto, and it was beyond it. And at that point, they said Pluto is actually part of the Kuiper belt, which is this collection of objects that orbit on the kind of beyond Neptune, somewhere between 50 to 100 AUs out. Here is an image of Pluto, and we could see a light haze on top, which is the atmosphere. Very thin atmosphere, but nonetheless, Pluto does have an atmosphere. And here we could see some of the terrain there. So what they consider the bad lines, rougher terrain there, mountain. And then we see some smoother terrain out on the right there. So again, evidence of some type of activity there. And here's another image of Pluto. This is taken from the New Horizon. So just amazing that we are able to just get images of such clarity. And so Pluto resembles what we consider more of a comet than it does one of the planets. It's probably just an oversized comet, and that's perhaps what most of the objects are in the Kuiper belt. And so briefly, we'll talk about some of the rings around the Jovian planets, and all four Jovian planets have rings. Some are just easier to see. Saturn has the most visible rings since they reflect light a bit easier. Here's an image, Saturn's rings seen from above and below, and you could see those grooves there that distinguish them, the different, what we call different rings. So they're labeled such as like a D ring, F ring. So they're alphabeticalized there to distinguish which region we're talking about. But they look much like grooves on a record. They're not solid. If you got close enough, you could actually fly through them. The objects would probably be the size of, small mountains, cars, houses, to very fine particles as well. Here's a nice detailed image of one of the moons. And so these act as shepherd moons. These moons clear out all of the debris within the path, and it keeps all of the other debris kind of on check there. So where you see these kind of grooves, there are moons in there that are keeping all of this debris kind of in line. These are the rings of Uranus here. And so the Voyager team was able to collect, to get some images here. And then they also were able to detect some of the noise here. These are a lot darker, don't reflect as much light, so a little bit harder to see. And then the rings of Neptune. Again, here a bit darker to see, and not as many there. There's kind of just two dense regions. So what exactly are the rings? Well, we think they're just debris floating around, perhaps moons that were going to form, and they collided. And so really what Saturn is right now is just kind of the accident of our time. If we look back perhaps a few million years ago, perhaps Jupiter would have had more debris around it, and it would have had the spectacular rings. But right now it's Saturn who has those. And it's just these moons that keep colliding and breaking up. Eventually they will break up into smaller pieces, and it won't have as many as rings as it does now.